All right, everybody. This week's big project is delving more into servers and kind of what they're used for. Now, on networks and things like that, servers are used to, you know, take clients and people like coming into the website, assigning them where they need to go. A game server would take in people and figure out what game they need to go to. But in real life, when you go to a store or something like that, they have servers that serve the customers. And they actually have programs and things like that that decide how many customers they need to serve, how many servers do they need open at any given time. Have you ever been to one of those big grocery stores and you see some of the lines start backing up? Generally speaking, if there's so many people in line, the protocol is to open up more registers, assuming you can. It doesn't always work out that way, especially at the stores I go to, but you know, this program we're going to make today is basically a little simulator. This allows us to kind of simulate a line. We can go in and just, adjust a couple of things here and there and see specifically how well our restaurant, business, whatever, handles a certain number of people at a given time. Now I'm going to make a lot of assumptions here. This is just more kind of a display than anything. But let's go ahead and talk about what we've got here. Now, I'm not going to write all this from scratch uh, because, well, it would take a while. So I'm just going to go through what I've got, and you guys or girls, whoever, are going to have to just make the projects. So I called this project Serve Me. So if you just make a new project, we're going to have a couple of different items in it. One, a customer, which is what we're going to talk about first. You're going to have to create a customer object. Now, a customer, there's a lot of things we could calculate, but basically this whole project is kind of a statistics program. It runs a little simulation, it sees all these people coming in, getting served, and it keeps track of how happy, unhappy, things like that each little guy is, or whatever that comes in. So our customer is going to have two attributes, and that is how happy they are. And for that, we're going to make a lot of assumptions, because I'm not a professional line person. Uh, Line engineer. I don't know. I'm sure if I asked Disney for help, they would be able to just flawlessly put this thing together because they are you know, the end all be all of lines. But what our happiness is going to entail is the longer someone's in line, the less happy they get. Uh, the line moves up, you know, they feel a little bit better. Think about how you feel when you're standing in line. Person in front of you goes in, blip, blip, and then they move on, the line goes up. Every time that happens, you feel a little bit better about the line you're standing in. But if you stand there for 10 or 15 minutes and the line has barely budged, you start getting irritated, right? That's kind of what I'm going for here. And wait time is how long this particular person is going to have to wait. Now that's going to be kind of decided by the server. So you can kind of think of this as someone sitting at a cash register, customers lined up, and they walk up and the server basically decides how long it's going to take to ring this person up. That's kind of how I'm going with this. So I'm going to set my customer's happiness to 100. Let's say they come in perfectly happy. That, of course, is never the case. I've had people come in line and then just, you know, immediately bolt out the door when they saw there's like 3 people in line. I've seen people stand in line for 10 minutes, get up to the register, and then just walk away angry because the cashier asked them a question. So, again, we're going to make a lot of assumptions here, but you'll kind of get the gist of how all this works, hopefully, by the end of it. So I've got my attributes, my constructor, and I set the happiness to 100, the wait time to 0 for right now, and that's going to change later. I got a couple of methods. Add is going to add happiness when the line moves, 0 to 2. So every time our line moves up and someone gets served, everyone in line will feel a little bit better. Now, subtraction will subtract the happiness. The longer you stand still, the less happy you get. Now, the way this is kind of designed, if the line's relatively short, it's, no one's going to be too disgruntled. But the longer the line gets, the longer it's going to take for everybody. People at the end of the line are just going to be livid, basically, by the end of it, depending on how long your line is going to be. And we can adjust that size however we want, but we'll get to that part later. Now, add wait. This method basically increases every turn. Keeps track of how many turns this person's been in line. So the server knows how long this person's going to basically take to finish. And the wait time is how long that person has waited in line. So if the server says it's going to take 3 turns, and a turn for what we're going to be doing is we're going to have a loop that loops. Customers are going to come in, they're going to get in line, the server's going to serve people. Every iteration of that loop, maybe someone will come in and get in line. Maybe the server will finish serving that person. Well, if they have to wait, every customer is going to have to wait. So the first person that's in line gets counted up. If they have to wait 2 turns, then the thing will have to loop twice. This will go up once each time, and once it hits 2, they're done. The server can get them out of the line. Now, get happiness is just a get method that gets the happiness. Get wait time is just a method that gets the wait time because it's all private. And this is happy. Well, I'm just going to assume that if they're 50 or greater, they're happy. And there's going to be a lot of folks that probably won't be, particularly if we make the line exceptionally long. But that happiness goes down the longer they wait in line. So as it goes down, they get less happy. And it's when they leave the line, we can use this to see if they were happy with their experience, so to speak. And that is the end of customer. So this kind of entails, these customers are going to be in our line. So we're going to have a queue of customers. So we're going to need our queue file that we had from our previous projects. And we're going to adjust it so it works with customers instead of listings or boxes or pigs or whatever. So one more rotation. Customer, attributes, my constructor, and these methods here, right here, the end. So let's take a look at queue and what had to change for that. Queue. So queue is pretty much the same as the queue we've been using. The only difference is it's working with a customer. I come down, it's a customer. Come down even further, that's a customer as well. All this other stuff is basically the same. DQ is the customer. And of course, I'm going to return null instead of -1 or something else. Now, I do have an extra little addition here. And this is increase and decrease. Now, if you notice, this uses the method add. This uses the method sub. Now, what increase is? We have our queue, a line of folks, and every time the person in front of the line has to wait, we're going to call this method. Which means basically, the size isn't 0. We have people in line. We need to basically make them, well, I should say actually, this is increase, so that's going to increase my happiness. So this is when someone comes out of line. So when someone leaves line, we go down the whole line and everyone's happiness increases. And that's what this method's going to do. We loop through our entire queue, and as long as the little thing in there is not null, and that's just a check to make sure that I don't accidentally find an empty customer or something, I just add, increase their happiness. So that basically comes over here to this, and their happiness goes up a random amount. So I'll go down my entire line, increasing everybody's happiness a certain amount. Now, decrease is the opposite. Notice it's pretty much the same code. The only difference is I'm using sub instead of add. So this gets called if someone is waiting in line. So each turn we have to wait. That's when this gets called. This gets called each turn someone leaves the line. Now there is another option we could throw into this. You know, when someone gets so mad they just leave the line altogether, we're not gonna deal with that. That's called balking. Basically, you're in the middle of the line and you're fed up, you walk out. Now, if we did that, it's entirely possible to make a method that does that. If someone reaches a certain unhappiness, let's say if they hit below 0 or something, then they leave the line. And we keep track of how many people left because of that. Because surely, I mean, people have waited in line and it just hasn't moved. I went to a restaurant once and was there for 20 minutes in line, and the line, like, of cars didn't budge, like, at all. I sat there and I'm like, well, all right, that's enough of this. 20 minutes and not a single move. Everyone has their limit, and we're just going to assume it's 0. Now, we're not going to program that, but if you wanted to know how that would work, I would say you would count the position of whoever it is that's angry. You'd have to go through the entire queue and find that person. Once you did, you dequeue everyone into another queue. When you find that person, you dequeue them and, you know, count them. They've left, throw them away, in queue everybody else behind them, you know, into the other line. And then you just move it back to the original line. Once you've done that, you know, you could take that person out. So that's how that could work. Basically, you'd make 2 lines, you'd remove everybody from the first one, and put them into the second. And once you found the person who is 0 or negative, you would just clear them out, and then you'd move them all back. That's one way you could do that. There are more efficient ways. You could just go down and, you know, once you find that one dude, you know, just go down and just bump everybody up 1. That's another way you could do that. I like my way better because it's a little longer, but I feel it's a little safer than just going in and messing with the queue outside of the bounds of what's set. So increase and decrease. And I had a display, but I commented out. We don't really care that much about that on this program. So there we go. That would be our customer. So the only thing left is to create a server. So I got a customer, a line of customers, and they have to stand somewhere, which is the queue. So they stand in the queue. And they get served by this server, rather. So here is the server. Now this is going to be, you know, 180 lines of code. So let's go through it a little bit here. All right, the server is going to deal with, you know, each server is going to have their own line. So if I had multiple servers, they'd each have their own specific queue. Now we get a serve time, which is basically how long it's going to take to serve the person who's first in line. The server themselves is going to keep track of who's happy and unhappy, how many people they served, how many people have entered the line. Basically, the server is going to keep track of all those statistics. When I take a customer out of the queue, which is already here in the server, I check to see if they're happy. Plus plus. If they're unhappy, plus plus. They got served, that goes up by 1. Every time a customer enters the line, that goes up by 1. So I can see how many people are in line. So these are my attributes. I move down to my constructor. I set the size, and this is going to be the size of the line that's allowed. Now let's go up here 1 sec. Oh, sorry about that. Had to pause for just a second. All right, where were we? All right, we created our server. All right, there we go. That should work. Okay. There we go. All right, now my sound's better. Okay. So I've got a server. It sets the serve size for the queue. So my business is relatively small. Maybe the maximum number of people that can fit in there is 10 or 15. Maybe it's like Walmart or something where you could go all the way down the aisle and there's like 20 people could stand in a line. We can set that size to whatever we need it to be. Initially, we're going to set the serve time to -1. And the reason I'm setting it to -1 is because 0 means it's, well, I'd say 0 on the customer means that it's, well, let me fix this, rather. This is going to be the amount of turns it's going to take to finish off the customer, to send them on their way. So -1 is never going to happen, so I'm just setting it to that at the start. We don't have anybody happy, unhappy, served, or customer entered at the beginning, so we just set those to zeros. Once we create a server, it's got its line, it's got its everything set, pretty much all the stats are ready to go. So we're going to have a couple of methods here. I'm just going to hide some of these. We're going to have add customer, which adds customers to our line. We're going to have check, which checks to see if, we need to get rid of our customer that's in the line, if we need to, if we have another customer that's come in that we need to get a serve time for. If we have a customer that is finished, we need to get them out of the line. And then we get a serve time for the other guy. And then we have a stats, which just simply keeps track of the stats and prints it at the end. Well, I'd say not keeps track of it. Most of our work is going to be in check. But let's look at add customer first. So every rotation of my loop, basically, I'm going to make a loop, let's say 100 turns. And each turn counts as maybe, let's say, a minute in real life or something. Not exactly, but to give you kind of an approximation. In the main, I'm going to have a little random number generator that's going to basically say, all right, 1 customer just came in, 2 customers came in, no customers came in. And if no customers come in, then this loop basically doesn't run. It runs, but it's 0, so it just stops and doesn't run any code. 1 customer comes in, we come in and check. What's the size of my queue? If it's 0, then, well, there's nobody in line at all. I get a serve time because my line is empty. Obviously, I'm not serving anybody yet. So I go ahead and tell the server to basically get a time between 1 and 3. So 1 and 3 turns to serve this person. I create a customer, and I put them in the queue. So and I have a little print statement here to let me know that a customer entered the line. Now, if I'm, like, say, 3 people came in, which is possible, I'll come in. If the line's not empty, then I'll just skip getting the serve time. That only happens if the line's empty. And then I just pluck the person, create the customer, put them in the line. Customer doesn't really have any stats other than that I have to worry about initially. Their stats go up and down later. So all this does is just simply put customers in line. Now check, which is going to do most of our work here, public void check. At the very beginning of check, we're going to say this is the number of customers in the line. And we're using queue.size. So if we go back to my queue, remember I've got this size variable that keeps track of how many people are in that line. So that's what that's using. So there's a customer in line, but it's not time for them to come out yet. There's a couple of different conditions we need to worry about. The first condition is somebody's in line, but it's not their turn. They got to wait. So if Q.size, that means the size of the line, isn't 0, and the serve time isn't 0, meaning that, basically there's somebody in line, but it's not yet time to serve them, then I will subtract the serve time. Serve time goes down. Bloop. Now, the customer waits, and then I print a little message how long they're waiting. That's, again, mostly just for my benefit to see. And I'm going to call that decrease, because everybody's waiting. I'm going to call decrease, which, if you remember on my queue, is going to make everybody unhappy a certain amount. It's just going to go down the entire line, and every single person's going to be like jabbed by the unhappiness stick. Now, else if. This is if, else if here. So the next condition is someone's in line and it's time for them to get out. So if my line is not 0 and the serve time is 0, meaning they're ready to go, I dequeue them, put them in this temporary customer basically, and I say they left the line. I increase the stat, served, so I know a person got served. And someone left the line, so it's time to increase everyone's happiness. That's what that does. There we go. And pop. And I'm going to check that particular person. Were they happy? Were they sad? And I'm just going to keep a tally of how happy everybody was that came in that left. Now, and at the end of this, somebody just left the line, right? So at this point, I need to basically check the next customer and see, what their serve time is supposed to be. So what this does right here is it gets the next customer's serve time. As long as there's somebody in line, basically is what this says, we'll get a serve time for them. And then I'll say, customer has to wait however long it is. Now the else here is if there is no one in line, it just says there's no one in line, there's nothing to check, no one's in line. Just going to print a little message. And that is the end of check. This is not too lengthy, but there is a lot of little things that are going on here. So one more time, I say the number of people in line, and this is going to get called every rotation of my loop, which you'll see here in just a minute once we get to the main. So I subtract the serve time if there's somebody in line but they're not ready to go, and then I make everybody unhappy. If somebody is in line and it is their time to go, I take them out and grab some stats. And then I get the next person's serve time. If there's no one in line, then we do nothing. Now, the stats is just a simple print. I just print, and this is going to print at the very end of my project, when everything runs, how many people were served, how many people were happy, how many people were unhappy, the total number of people in line at the end of this, and the total number of customers that entered. Now keep in mind my queue has a certain size, and if customers come in and try to get in the line and it's already maxed out, they won't be able to come in. So there may be a little option here where we keep track of people who came in but couldn't get in line, but we're not that concerned about it right now. So let's check out the very last bit, which is the main. Now you'll see the main is very, very small. It doesn't really need to be large at all. So I have a global variable, public static server s equals new server, and I made the line size 100, meaning 100 people could stand in this line. Now, once we build all this, we can come in and adjust this and see, how long our line needs to be before people really get unhappy. We could add more servers. How many servers do we need to have to handle a certain number of people coming in? There's a lot of stuff we could adjust and see to give us some information to help kind of improve our own business or whatever it is we're making here. Now, first off in the main, after we've got our server declared, is I've got this for loop here. And I'm just going to set it to go, let's say, 500 turns. And each turn, let's say it's a minute or something. Or just so you can kind of have an idea of how it's working. First thing I do is I print off the turn number. And then I get a random number. And this random number is how many people are coming in. And now notice it's going to be between 0 and 2 people per minute, which is a very busy business actually. But, you know, if it's a 0, nobody comes in. If it's a 1, one person comes in, and then we add one customer. That add customer is right here. You know, 1, it loops and adds the customers to the line. Now if it's 2, well then we will add 2 customers to the line. Now, at the end of this little if statement of customers getting in line, we call check. And check decides to see if anyone needs to come out, if we need to get serve times. It deals with all our statistics. Then I have a couple little blank lines just to print. And at the end of this for loop, after everything is said and done, I print some stats. So let's take a look at what this looks like when we run it. Now I've got a couple of spaces here, and you see there's a lot of turns. As a matter of fact, it's probably safe to say that if I scroll up, it's going to take a little while. There we go. It's lengthy. So 2 customers came in. Customer tried to get in line. The line is empty, so the customer got in the front. Customer enters the line. And this customer gets in the front comes from the queue, I believe. Right up here to in queue. Customer tries to get in line. They can't enter, it's full. Line is empty, customer gets in the front. Line isn't empty, customer gets in the back of the line. That's where this is from, this in queue here. And it's just more information so I can see what's happening a little more visually. So, 2 customers got in line. Boom. 1 and 2. And number of customers in line at the end of this check is 2. Now the customer has to wait 1 turn. So on turn 2, you know, well, this is at the end of this turn. They have to wait 1 turn, I should say. So that means they're going to finish on turn 3. So another customer came in. They get at the end of the line. Line's not empty. Customer into the line. We have 3 people in line, and customer 0 is about ready to be checked out. Now, you'll notice the way we got this kind of set up, the line is going to, with 1 person serving, the number of people coming in is way more than our serve time is. Our average serve time is 2. The average number of people coming in is 1 per second. So just because of how we got it set up, our line is going to get bigger and bigger and bigger the longer you add on to it. So we can go down this whole list all the way to turn 500. And at the very end of this, you'll note I've got 162 served. 65 were happy, 97 were not. 99 were in line, which means my line was completely full. But I had 500 people walk in. So if you do the math, you know, this plus 100, half of thy customers walked out. Not exactly a good way to go about things, right? Now, let's say I made my line 20. You know, most of my customers weren't happy, actually. So I run this again. Now, all my customers were happy, but I still had a whole bunch of people like walk in and walk out. But the actual customers that were served were pretty much overwhelmingly happy. Now, if I make this 200, now we've got, again, Our serve is basically the same, so we're going to serve about the same number of people, happy and unhappy, and the line's still maxed out. Looks like we had, of course, they can't leave the line, so they're kind of trapped there forever until we set it otherwise. But as you can see, just adjusting this a little bit, let's say 50, completely changes kind of how happy and unhappy everybody is. So this kind of gives you an idea of how you can, if it was an actual business, adjust your lines, number of people running registers and stuff like that to kind of mess with the stats and put them where you want them to be. This is way too many people cutting out of my line, basically, not coming in. So in order to fix that, I would probably need multiple servers. One is not going to be enough. I would need 2 or 3, and then I could handle this volume of people. And of course, having more servers means I would probably have more happy customers because all the lines would be moving. But that is a question for another project. All right, that is essentially ServeMe. Just a simple Lime simulator. And again, we got customers, queues, which again, my queue is, I've got a couple of little print statements here for DQ, just to be a little more descriptive. And my server, which does the bulk of all the work here for the most part. But you see, each individual thing isn't dreadfully long. I guess queue is still long, but about 80, 90, give or take. But it does give you a lot of information on that can be useful in real life. Now, again, take all this with a grain of salt. I'm making a lot of assumptions here with the happiness and all this stuff. Typically, people have studies, and they could probably give you much better metrics than the random number generator that I just plucked out of the air. But it hopefully gives you an idea of how this can kind of work and how this type of program can help a business, particularly if they have line issues and things like that. Oh, and if we wanted to further make it more interesting, I could make my server like each individual server I created, and I could create multiple servers. I could come up here and just make another one if I wanted to. S2, Alt Shift F, there we go. So I could have 2 servers, and then I could write some code so I'd have 2 lines instead of 1. But each server doesn't necessarily have to have this 1 to 3 serve time. Maybe some servers are slower than others. Maybe some are faster. I could adjust this here. So, whenever I do this server created, I can give it a serve time to perhaps like a number of, not specifically serve time, but maybe serve speed. And I could plug that in here. And that would adjust the average speed at which they serve people. More experienced people would go faster, newer people would go slower. If you wanted it to be a little more realistic. Again, we're not that concerned, but it's a good idea to know how that works anyway. Anyway, that is a quick little rundown of the server program. Forgive me for rambling a little bit here and there. But hopefully, I'll just erase you back. Oop. Play around with it a little bit. Adjust some of the numbers. Instead of 500 turns, let's say 200 turns. Completely changes kind of how this looks a little bit here. Come on down, let's see, server size, let's say I had it at 100 before. Well, now look, there's only one unhappy customer. 67 were served, 66 are happy of the 67. We're just starting to see that unhappiness fold. We have 100 people in line, unfortunately, which means about 30 or so walked out. And that could be a stat you can figure out just by doing some simple math. Add the number served, add the number of people in line, and subtract. And you would know how many people walked out. That would actually probably be something I'd want to know. Let me see here. We'll just go ahead and add that. Let's do this. We'll just make it walkouts, just to have it in there. private int walkouts. And we'll just say walkouts equals 0. It's going to equal 0 anyway, but so at the end of the stats, I'm just going to say walkouts equals, let's see here, served plus queue.size. I have to subtract customers entered, so minus queue.size. There we go. Number of walkouts. And if I run my thing here, this should be about 30-ish walkouts. There you go, 30. And it's going to change because of the random generation, but you see, now we know exactly how many people have walked out. And if I go and adjust this to where we were going like 500 earlier, we would get upwards like 200 and something walking out, 250. So there we go. Now I know how many people walked out of my thing as well. All right, well, hopefully that clears a few things up. If you have any problems, of course, you can always go back and pause and go back, uh, rewrite some stuff. But if you have any issues, you can always message me as well. Hopefully that is everything you need. If you have any questions, let me know.